Good afternoon, everyone. Thank you for joining us today for choosing the right 3D printer, what you need to consider before buying. My name is Diane and I'm part of the marketing team here at Solidscape. Just a few housekeeping items before we begin today's webinar. All participants are in listen-only mode. Your microphone is muted, but we do encourage your questions. So please submit any questions by typing them in the lower right-hand corner of the toolbox panel, and we will do our best to answer them during the Q&A session that we will have at the end. Okay, let's get started today. We are pleased to be joined by our panelist. Vincent Icart is the MOVINGLight Director at Prodways, and he's going to do a comparison of different printing technologies. He's going to walk us through that today. Sherrie Kysilka is the owner of CADVantage Modeling Services, and she is going to take us through and answer the question, are you using the right technology to set you apart from your competition? We're also joined by Owen Burke from Solidscape. He is one of our directors here, and he's on with us as well today. And then that will be followed by James Cook. James owns Tate's Gallery. He's a local jeweler in New Hampshire, and he's going to talk to us about the benefits of owning your own 3D printer. Then I'm just going to wrap it up with a little bit of an overview about equipment financing. So let's get started. I'm going to hand it over to Vincent right now, and to take us through a bit about various technologies.
All right, let me share. All right, can you see my screen, Diane?
Yes.
Okay. So, hi everyone. I'm Vincent Icart. I'm pleased to give you an overview on the 3D printing technologies for jewelry. I've been with Prodways and Solidscape for 5 years now as a technical expert and a product leader in resin-based systems, and I've been working a lot with customers directly for jewelry, dental, aeronautics, and other applications. Today, I'll cover different aspects. So what we'll learn together, what are the different printing technologies, what are the different materials, because printer is nothing with the associated material. How does this relate to the final part in terms of surface finish, casting, models accuracy, details, and some cost consideration. This is a very, let's say, high-level presentation. If there are some more technical questions, we'll be very happy to take the question at the end of the webinar. So 3D printing and jewelry, we have actually an array of technology. We try to divide the 3D printing world into two main types of technologies driven by the materials. So on one side, on the left hand, you have the resin-based systems, and on the right-hand side, you have the wax-based systems. The resins are UV curable materials, while the wax are melting materials. There is obviously borderline cases because there are some wax-filled resins. We'll give some details on that later. The resin world is subdivided between three main categories, which are DLP, LCD, and SLA. DLPs is a technology that is similar to your video projector at home. LCD is a technology that is similar to DLP, but more coming from the tablet and smartphone industry. And SLA is using a laser to cure the resin. Those three technologies can be implemented in terms of layer addition, either top-down or bottom-up. So one machine is upside down compared to the other one. We'll see the benefit, the pros and cons of each of those concepts. And in terms of post-process, well, this is a liquid resin. So after printing, we'll be needing to rinse the part into alcohol, hand clip the supports, and UV post-cure. And very important for you, this is an acrylate material, so it's actually burning during the casting process. For the wax materials, I'm sure you recognize on the right-hand side the crayons from Solidscape. We have raster-based technology, which is using an array of nozzles. And we have the vector-based machine that are using only one nozzle. We are printing the parts onto supports, which is dissolved into appropriate solvent. And because this is a wax-based system, for the casting process, we are fully melting and vaporizing the material. Before jumping on the technology, I'd like to give you some details on 3 keywords because they are very frequently referred into the marketing contents of everyone. So I'd like to make sure we all speak the same language. First of all, the resolution. So the resolution is what is the minimal feature size that the imagery system can render. This is frequently expressed in dot per inches or in pixel size. The accuracy is referring to, are you correctly positioning this feature of a given size? And the precision is answering the question, is this feature always correctly positioned? On the left-hand side, you can see those dots schematics to display what is the difference between resolution, accuracy, and precision. As you will be getting the slide, you'll be able to get more details on those images. Next, very important concept is the layer thickness and comparing it to the XY resolution. So the layer thickness is depending on the material delivery system and on the platform motion. The layer thickness is actually the resolution for the Z-axis, as opposed to the XY resolution that is depending on the lighting and on the lighting system. The layer thickness and the XY resolution are usually not the same. The Z resolution, which is given by the layer thickness, is actually user selectable, because the user are always free to modify the part orientation so that to have the proper Z resolution depending where you are willing to have the accuracy. So the resolution of the printed part is depending on the build orientation, while the XY resolution is fixed by technology design. Let's talk more in details on the various technologies. So I explained to you, we divided the world between resin and wax. What are the main differences? So on the resin side, you are solidifying a resin that is liquid by UV light, and the resolution is depending on the imaging system. Because of the pixel grid, if you have a small pixel, you would have a high resolution and a small bit envelope. And for laser system, if you have a small spot, you will get high resolution and a small speed. Because we are printing in liquid materials, we need to build parts on a lattice structure of the supports that will be removed by hand clipping as a post-process. The parts are usually very strong with the resin as opposed to the wax that is melting. And the post-processing is
Hi, Vincent.
Yes.
It's Diane. We're having a problem seeing your presentation. I think we're not on the right slide. It's not in presentation mode. Can you just check that to make sure? Okay.
Can you see it now?
Yes. Okay. So you just need to go to the slide that you're on right now.
Okay, that's strange. I was in this mode, but my screen flickered, so there might have been some kind of a bug.
Okay, perfect. Thank you so much.
Okay, so let me recover from there. So the post-process for the resin is cleaning the excess resin, hand clipping, and posturing the parts. For the burnout, so remember, we need to burn the resin. So there might be expansion during this process with associated potential cracks that are depending on many parameters. This may also leave some hashes that are called hash residues, and it's producing some smokes. For the wax, we are depositing some droplets. So the XY resolution is depending on the droplet size. Small drops is high resolution and low building speed. The material is actually jetted, and we frequently have two materials that are the build material and the support material. On the Solidscape printers, the support material is system generated. The parts can be fragile to manipulate because of heat, and the post process is mainly dissolving the support into a solvent that's called the VSO. Regarding the burnout, the process is the same as injected wax, and it produces no residues because the wax is burning. Let's quickly talk about the printing direction. For the resin wall, we have two approaches: left-hand side, the top-down, and right-hand side, the bottom-up. So on the top-down approach, on the left, the light source is above the liquid vat. The light is sometimes motion depending on the system above the liquid material, and it's a step-by-step Z motion. The benefit when you have a moving projector is that you can achieve a very large build envelope. The compromises with those technologies that it's frequently a capex that is a little bit bigger compared to other technology, because you need to fill a vat of resin. So you have an initial fill. And with the laser-based system, you might have some skew effects in the corners, meaning some discrepancy in the quality depending on the position on the platform. For the bottom-up technologies, the light is below the vat, and it's also a step-by-step motion. It's usually very small build platform, so you can fit 5 to 10 pieces per print. And there is an option to play a little bit with the oxygen so that to reduce the layer line by printing continuously. There are some increased operating costs with those technology, because you see that we are actually curing through an interface that is a vat, and this vat is aging because we are constantly peeling the previous layer from this medium. So that's a cost that needs to be accounted for. The oxygen-enabled machineries are having some challenges with very large sections, because there are some flowability of the resin consideration. And again, when you are using a laser, there might be some skew effects in the corners. Let's talk about on the imaging technologies. So this is referring to the XY resolution, if you remember the previous slide. We have three main types of imaging systems. We have the DLP. So DLP is a system that is inherited from Texas Instruments, and it's the same technology that you have at the movie theater or in your video projector at home. We are using a grid of pixels to cure the resin. So frequently, it's possible to have very high accuracy, because it's possible to design optics that enable a very small pixel size that is beneficial for tiny details in jewelry. Depending the projector that you choose, this may get expensive when going to 4K, and high power UV LED may be expensive. It could be a rougher surface compared to wax technologies or laser, because we have limited number of pixels that are enabled on or off. LCD is in a way similar to DLP. We are handling a bunch of pixels. There are multiple light sources to bring more energy, and it's inexpensive. Some limitation is that this technology is driven from the smartphone and tablet industry, meaning the pixel size can be quite big, which means less resolution for jewelry. We also have some similarities with laser technology because of aging. So the LCD itself can age, and you need to replace it. The laser ensures a very high surface finish, because you are actually drawing the curve like you are doing it with a wax system. Um, I'd like to go quickly on that one. So this is a representation of DLP and LCD compared to laser. On the left, you can visualize that you have an array of pixels that you can control. So curing with a DLP and LCD machine is actually a stamping process when you will be curing all those pixels at once, as opposed to laser, where you'll be having a continuous motion to draw the contour of the part. Now let's take a look at wax printing technology. So we have two main families. On the left-hand side, you have the raster technology, and on the right, you have the vector. These two technologies share the same basis. You have a nozzle that is jetting a material. In a raster machine, you will have multiple nozzles. In a vector machine, you will have a single print head that will draw all the contour. The raster is usually a high speed because you are jetting multiple drops in the same pass, but the surface finish can be not equivalent into the XY because of the on-off jetting. On the vector base, you are enabling a very high surface finish, allowing for less metal polishing. So that's a huge benefit. Of course, this is one drop at a time, so the speed is not the same as on a raster machine. Now, let me summarize this presentation. So in the resin world, you have two interesting technology, which are moving DLP and DLP. The moving DLP is using this DLP technology that I was mentioning, but we actually move this projector above the platform so that we are keeping this very high accuracy, but enabling it on a very large bin envelope. Typical application is mass production for jewelry. So the moving DLP technology in what word is productivity oriented. On desktop DLP, these are very good machines for quick small prints, but because of the reduced build envelope, you are only enable quick prints in the design phase. So that's more oriented towards one-off prototyping. And finally, with wax vector printing, so these machines are, let's say, benchtop size. The key benefits is an extremely good castability with unmatched surface finish, details, and precision, both coming from the fact that we are using a material that is melting, but also that we are rendering very finely the geometries since we are detailing all the contour with our single nozzle. In one word, I could summarize that it's a zero compromise solution because everything for a jeweler is here, both castability for good surface finish together with extremely good rendering and fidelity with respect to the target geometry. This is concluding my presentation. I think it was a lot of information quite fast. Sorry if I was talking a little fast. I'll be happy to answer any question at the end of the session. So thanks again for your attention, and I'll talk to you later in the chat.
Wonderful, thank you. That was a lot of great and very helpful technical information. We really appreciate it. Our next guest today is Sherrie Kysilka. She is the owner of CADVantage Modeling Services. She's a master jeweler, a former educator at the GIA, and she's also a CAD designer. And we also have Owen Burke on the line with us as well. He's one of our directors here at Solidscape. He's got 15 years experience in 3D printing, and he supports our global business here at Solidscape. So Sherrie, I'd like to hand it over to you and Owen, and maybe you can kick us off by talking about the 3 must-have criterias for choosing the right printer.
Hey, Sherrie.
Thank you very much. And hi, Owen. Thank you very much, Diane. And first, I just want to thank you guys for letting me share my over 2 decades of 3D printing experience with you folks.
Great. Thank you, Sherrie.
All right. So first of all, this is what we're going to talk about. 3 basic must-haves. Now, don't get me wrong. There's a bunch more, and that will be available to you in the future. But the ones I'm going to talk about today are dimensional accuracy, having the material and the models be directly castable without any potential issues, and then making sure that you get beta parts from all the different machines that you may be interested in, so you can compare your beta parts both in model, the finished model that comes off the machines, as well as directly casting them to be able to identify and gather criteria that can help allow you to make a wise choice.
Yep. So Sherrie, there's a lot of changes in the market, and we've seen a lot in the last, just in the recent last couple of years, if not the last 5 years, a lot of changes, and the market seems to be flipped upside down to a certain degree. So a lot of customers and prospects are looking at it and saying, okay, there's a lot of different things out there. How do I do my due diligence? And what you're suggesting is that they send a file to the 3D printing company, reseller or manufacturer, and asking them to print you a sample part or a beta part, and going through the process of evaluating that from the STL, the CAD file, all the way to the casted piece, correct?
That's correct. It is critical. And the biggest reason is this. If you're a jeweler and you sit down at the bench and you have problems with the model that you have, it could be in the technology that you purchased. And this is the way to avoid that. Pardon me?
Proof is in the pudding, right?
Absolutely. I'm not from Missouri, but I want you all to show me.
Right. Exactly. Good.
So let's go to the next slide, please. I don't know how to do that. Nobody ever.
Yep, we're good.
All right. So I've got several pieces of different technologies, and we're going to be doing just a little bit of an evaluation on all of these pieces. So this is an example of non-dimensional accuracy. Okay, and the reason is this. If you look at where the yellow arrow is, you'll see how what should have been, in jeweler's terms, relatively a cushion shape, as the result of being a single material system, it began to, for lack of a better word, distort, okay? And, obviously, this is actually both gravity, which has pulled on this, as well as the likelihood being inaccurate screwing that was done on this, or gating, when this was put on the machine. So some people will, add more or less support, and that's the issue. Is with a lot of other technologies, you have to figure out what works, and you're not going to know until the piece comes off if it worked or not. And because of the 2-material system that Solidscape is, I prefer something like that, of which gravity has absolutely no effect to distort the models. So it allows me to basically produce anything, and I really don't have to think, oh my God, did I add enough this? Oh my God, is this going to be this way? Yeah, am I going to lose 12% of my model because of distortion? All right.
So you've been using Solidscape machines as well as other types of machines for a while, Sherrie. And from your experience,
go ahead.
So no, I was just going to say that based on your experience over time, trying other things, that Solidscape has been a true tried tested technology that shouldn't be ignored, given there may be other players on the market today, because of the print process that we use is so important in how it fits into the overall process for a jeweler, so that other factors don't come into play.
If we were making very large parts, where dimensional accuracy is not as critical, let's say. So you may be making CAD parts that will be later machined versus 3D printed. This particular technology, the 2-material system like Solidscape, really it provides virtually no distortion that can affect the overall outcome in a finished product.
Great.
And I bought my first Solidscape machine in 1998.
Were
And
they
over a
making 3D
period
printers back then?
Yeah, well, yeah, and you know, that was when I started to first realize there was a wheel. Okay.
Yeah.
Anyway.
Right. There you go.
But the bottom line is over the years, what I have done is I have asked and received many other types of parts to see if technology was improving, if the resins were improving, and that kind of stuff. So I have literally a huge box with probably 80 different parts that were samples given to me to let me make the right decisions on things. Right. So in this particular slide, this is what I call my beta part. This is the part I have given to almost everybody out there. Obviously, not all 3D printers are good for jewelry, but the ones that they say, oh, we're good for jewelry, I send them this part. In this particular case, on the left-hand side, I have my Solidscape part, and on the right-hand side, I have a printer, or I have a piece grown by another technology, a resin technology. And the first thing I want you to notice is down in the head, the center area with the 6 prongs, the Solidscape part grew true to the CAD file. On the other side, you have one where, because of the printing technology, it closed up the bottom of the hole with resin. So if in fact you later went to cast this, you'd be using metal and wasting gold or silver or platinum that didn't need to be there. Secondarily, the diameter of the head in the center on the right-hand side piece is almost a full millimeter smaller than the CAD or the Solidscape part. So what does that mean? That means that what I made this for, the stone in the center might not actually fit without a lot of manipulation of those prongs, changing the angles on them and so forth in order to try to get the center stone to fit.
Hey, Sherrie.
Yeah.
So, you know, I'm not a jeweler by trade, you are, and I've been
Right.
talking to jewelers like yourself and others for a long time now and learned a lot. What I've heard and seen, a lot of jewelers wouldn't find this acceptable, even by the smallest amount of measurement being off, right? So being a non-jeweler, I look at it, yeah, it's no big deal. It's, you know, very small difference, but to a jeweler, that is a big difference. It can cost them some money in the casting process and overall in terms of producing the part that they intended to produce in the first place, right? So,
absolutely.
You should find this acceptable, basically.
In this particular case, since it's almost a full millimeter, all right? What that means, and the truth of the matter is I just gave the dimension of the head. There were other things like this on this particular piece. For example, the width of the prongs, okay? The width of the prongs was right in the left-hand model, and it got narrower, which then meant if you went to cast it and clean it off, the prongs might be less than optimal for stone setting security.
Okay. That's important, obviously.
Yeah, oh yeah. Nobody wants to lose that 1 carat diamond.
Right, right, exactly. Who would be responsible for that? So we don't want to be in that situation. Yeah.
All right, next slide, please. All right, now, not only do you want things to be dimensionally accurate, but you also want them to be directly castable. In this particular case, I have the same model, the left-hand model grown in Solidscape and cast in platinum, and the right-hand model grown in a resin material and then cast in platinum. And I don't know about you, but just looking at them, which one looks better? I'd say the one on the left. But what's more important is if you look at the surface finish on the bottom 2 images and the surface finish and compare them side by side, you'll see that basically what happened is the one on the right-hand side, it absorbed liquid. And the liquid that it absorbed also had a tendency to distort the surface greatly. And again, these are identical CAD models and everything else. The other thing is, if you look at the top left picture, and you'll notice that there's a dark line between the prongs, where there's a small amount of space, right?
Right.
Because you want the prongs to be manipulable. On the right-hand side, on the top right-hand image, you see where they basically fused together. And if you wanted to use that, you would have to try to separate that, maybe with a very fine saw blade or some other method, but that just adds time, and time is money.
Right, right. And that's a platinum piece. Would that be
Those
difficult?
are both platinum.
Would that be a difficult thing to do?
To separate them, no.
Okay.
But the other
From
thing
a cost perspective standpoint.
Yeah, from the cost perspective, if you look, and you can particularly see it on the lower two images, if you look at the thickness of the gallery wires, okay, and you'll notice that the gallery wires expanded. If you expand something, you're adding more mass. More mass means more platinum weight or more gold weight, etc. And so you would be paying more for what you didn't want to begin with.
Right, right. So that's probably something very important, especially in these times where our cost to manufacture is very important. So we need to be able to manage that accordingly the way we intended it. But we have to use the right tool in order to do that, you know, maintain our expectations through the manufacturing process.
Absolutely, absolutely, no doubt about it. Okay, let's go to the next slide, please. Next slide.
Yeah, I think we're there.
Ah, there we go. All right. Now, again, going back to, not only do we want it dimensionally accurate, but we also want it to be directly castable. All right. Now, these particular pieces were grown in a non-Solidscape material. And what I did when I got the pieces and cast them was I looked at the original information from the CAD file, which I have marked on the images as STL. Okay, so let you know what it came from. And the width of the shank, and I'm talking about the left-hand image with the left-hand white box, was 2.9 millimeter, okay? When this was cast, it grew to 3.05, and I put a little plus there because one side was 3.05 and the other one was like just a little bit bigger, like 3.08, okay? And then if you look, this is a two-piece halo casting. And then the upper area where you can see the STL diameter of this top piece was 11 millimeter versus the finished casting of 10.9 millimeter. Now, here's what I always think is the irony, is that not only is it not accurate, but you'll notice one grew and the other one shrunk. So because of the dimensional issues with other machines being a single material system, it is highly difficult to even attempt to predict how do you alter your CAD file to make this not happen. All right. Now, if you think to yourself, well, who cares? All right. Well, here's an example. On the left-hand picture again, the shank width is a 5% growth, okay, over the original file. So you're paying a little bit more. On the other side, it's a little bit less. So that balances it out, but it's still not going to help you if accuracy is necessary for stone setting.
Right.
And that was only a 1% difference. All right, so go to this is the same two pieces, but a different viewpoint. And I'm showing you this because this gives you an idea what you want to measure when you do your beta parts. That's why this is critical, so you can figure out what's going to work for you. So on the right hand, we have the STL file. At the 3 o'clock and 9 o'clock positions, on the STL file, it was both 2.0 millimeter. All right. And then underneath where the halo would sit on top, it was 1.4 millimeter thick in the STL file. So flip side to the other side of the box, on the after casting, it went 1.6 millimeter, which was a 12.5% increase. And then over here, it went 215, which was a 7% increase. That's substantial.
Right.
Now, then what's interesting here is, remember on the top, on the other side, it shrunk, right? Just 1%, but it did shrink. And then on the inside of the finger hole, you'll see a side view. And the STL file for what we would call the safety edge on the halo part, in the STL file was 0.8. After it was cast, it was 1.0. That's 20% distortion.
Right. So
bottom line is that it is difficult to determine the dimensional accuracy in anything but a two-material system.
Okay, understood. Good.
All right, so my suggestion, and I've done this for years, is beta test before you buy. And what you need, here's just 5 bullet points that you want to pay close attention to, and that is have beta parts to get printed samples before you purchase a machine. And here's this important part. You give every machine you beta test the same file. It's just a control in this experiment, so you're comparing apples to apples. And when you get the materials, the actual printed items, use your personal measuring device. Now, you want to see from, if you have the CAD file or if you don't have the CAD file, you'll be able to see which one is more dimensionally accurate. Now, I suggest that you use your personal digital measuring device, and like a Mitutoyo caliper, for example. So you measure and record your 3D printed model's dimensions in the exactly identical locations, okay? And then after you get all that, you cast your samples. And I'm going to tell you, you can cast them in silver. It doesn't have to be gold. And then you collect and document that data. And the other important thing is after you've cast it, you want to make notes on anything that you might see in the difference between the models, like the surface finish, or maybe a porous texture because of incomplete burnout, that kind of thing.
So whether you're buying a new machine or if you're going to be using a service bureau, you want to go through a similar process of, regardless if you're buying, again, a machine or you're going to work with somebody that has the right technology that provides the services for you, right?
That's critical.
Right. At the end of the day, you're doing the same things.
I've actually had a couple of my CADVantage customers who had relationships with service bureaus print some things, and they're like, I don't understand, you know, the finger hole's 3/4 of a size too small, when I know I didn't make it. And so, I mean, it's that critical, especially if you're going to do something like an eternity band, where finger hole is absolutely imperative.
Right. Agreed.
All right.
So
go ahead.
No, I'm sorry. Go ahead.
So ultimately, when you purchase a machine, and whether you're making master models for mass production or you're doing one-of-a-kind one-offs, you want desirable casting results. All right. Now, the layer thickness, which, you know, back in the old days, we used to call that resolution, but we know now that we're not only just the dots that are being put down or the amount of material, plus for Solidscape machines, the SCP technology, which stands for smooth curvature printing, that allows and provides a very nice smooth surface finish. So it's a combination of those elements that give you a really beautiful finish on your printed model.
Yeah.
Okay. Now, again, have to be directly castable with no ash after the burnout, because you're going to get spongy, porous castings and something like that. Well, you think, oh, okay, well, maybe I can laser weld up a little bit. But what happens when that happens to tiny little pinpoint prongs, where they just snap right off when you go to set them because it's spongy metal? All right. And then the other property that is really great is what's called, for the models to have zero coefficient of thermal expansion. And in Vincent's presentation, he was talking about investment breakdown. An investment breakdown happens when the models expand in the oven because you're trying to melt out the material. And that investment breakdown can also then translate into really rough casting, ones that you don't really want to spend time doing anything with. All right, and then the other thing is you saw that not all casting investments work with all printers, materials, and all precious metals. And you saw that earlier with the growth of the file and everything else. Now, we all know this statement that I'm going to make to be absolutely true, and that is time is money. So in order for you to spend your money wisely, you have to collect your data for critical criteria and make an informed decision on what you're going to buy. Now, I've provided a PDF file that is supposed to be on your website in the very near future. And people who are listening will be able to download this PDF file so you can understand the methodology and all the criteria that I think. And some of the criteria that are really important is having material available, having highly trained technical advisors. So if you're having issues, you know what to do. You guys do a calculation for an ROI, which is return on investment. So you spend your money, you can figure out how long it's going to take you to recoup your money very easily.
Yep. No, that's great.
That's it. You know, I encourage you people to do your due diligence, because otherwise you're going to be going, gosh, I wish I'd have done something different. Woulda, coulda, shoulda.
Right.
Exactly. Well, thank you, Sherrie. We appreciate your time today and joining us. That was a lot of great information. We will have that download available on our website later this afternoon. So we thank you. We thank you for your insight.
My pleasure. Have a great week.
Thank you
Thanks.
too, Sherrie. Appreciate it.
Now we're going to hear from James Cook. James is a second-generation goldsmith. He founded Tate's Gallery in 2006. He and his lovely wife, Sarah. They're located in New Boston, New Hampshire. He's a member of the League of New Hampshire Craftsmen. And right now he does a little bit of everything, but his custom business is really booming. And he's here to talk to us about the benefits of owning a 3D printer and how it can help you grow your business. So James, if you want to take a couple minutes and give us some insight on that, that'd be great.
Hi, everybody. James Cook from New Hampshire. I'd like to talk to you for a few minutes about how I got started. My family has run a goldsmith and a gallery jewelry business in New Hampshire for almost 50 years. I think I was about 17 years old when I officially went to work for him. When I first started, I never really thought that I would get involved in the full manufacturing of the business. My dad was a very proficient wax carver. He did everything by hand, and that was pretty much the only way that he did things. We did buy a lot of parts and pieces from different binding companies, and we would do little commercial put-togethers. Over time, working for my dad, I got really, really good at making those little put-togethers, buying a shank, buying a 6-prong setting, soldering them together, maybe drilling holes down the side of the shank to set little diamonds in. That seemed to be the most affordable way to make a custom piece of jewelry for somebody, and be profitable and do it fast. When I went off on my own from my family business about 15 years ago, I seemed to have thrown myself into the fire. Everybody wanted something hand carved. I learned how to hand carve waxes, but I never became as proficient at it as my dad. He seemed to be able to just whack them out one after another. Yes, they were sometimes were a little wonky, but that was sometimes the selling point, the charm of having a handmade piece. So about I think it was like maybe the first day of me working for my father, he explained to me that time is money. Like Sherrie said, it's, I think, probably the driving force in every decision I make in this business. Maybe it's because he drove it into my head for 15 plus years working for him at the bench, and he'd question me why I did something and how long it took for me to do it. I kept bringing that question into my life as I started my own business about 15 years ago. One of the first purchases I made was a laser welder because time was money and I needed to get things done fast. And a few years later, I realized that all the requests for all the hand carved wax models were growing so fast, and you know, it was kind of, at the time I would almost try to talk people out of doing a hand carved wax. I would bring them to the book and I would say, look, I can buy this shank, I can buy this 6-prong setting, I can weld them together. But people came to me because they wanted something that was made 100% here in my studio. Like a lot of my original one-of-a-kinds, they wanted something that was unique to them. So when I first purchased my first 3D printer, I did look at quite a few. I was comparing to mills. I was comparing to other 3D printers, none of which seemed to have had the time savings as the Solidscape. I didn't want to do a lot of work to the wax models. I didn't want to have to spend time cleaning up sprues in wax, and I definitely didn't want to have to spend the time cleaning up those little connection points in the metal. I looked at it as a waste of time, and really time was money, and I really needed to find something that, you know, I didn't have to touch as much. So the 3D printer from Solidscape, I first got the Studio, their entry level 3D printer, and it brought me into the Solidscape family. The smooth models that the Solidscape printer gave me was what I needed. I didn't want to do a lot of wax work. I could put a little connection point on it and go right to cast. I had a clean model. I could send it through tumblers and mass finishing processes and get it done quickly. I also could now print all my other easy little findings and wedding bands and shanks, half shanks, all those other things that I'd been buying from casting companies. Really is what made it worth it. When I was first trying to figure out if it was worth it financially, I really looked in deep into how much I spent on all of these casting companies and all the simple wedding bands that I just purchased from them. When I actually added that up, I was actually really shocked to find out how much I spent on a yearly basis. It was great. It was great to know that I was doing the right thing after I saw those numbers. Sorry, I just got distracted. The numbers actually made sense for me to go out and buy this printer. Also, I was looking at maybe hiring an employee, somebody with wax carving experience, and I could have paid somebody like that $50,000 to $100,000 per year, and still not got what I was trying to explain for them to make. Let's see, increased revenue stream. I think that came back to me saving all the money on not buying parts and pieces from all the different bindings companies. The flexibility of me being able to have my own printer instead of using a house to print them for me was, I couldn't imagine it any other way. I couldn't imagine sending my STL files to another company and then have them send it back to me in metal just to find out that I would have liked to have changed something. So being able to see a model before I showed it to my customer and then make a couple quick changes to it was huge. The quality control changed for me, allowed me to be very accurate. Let's see, what else can I talk about?
You can jump in. Thanks, Shane. Well, I think that pretty much covers it. And, you kind of went through everything, and we really appreciate you giving us some insight to your business and how having a 3D printer right on hand has helped you. So thank you so much.
Thank you. Have a nice day.
Thanks, James. You too. So we have about a minute left. I just wanted to talk about very quickly about, that we do work with CIT to provide folks with equipment financing. There's a lot of benefits to equipment financing, and it's a flexible alternative to cash. We have some information on our website about this, and we'll also have this slide available on our website as well later today. Unfortunately, we've run out of time for questions, but we will, if you did submit a question and we were unable to answer it, we'll respond directly to you. And we thank you for joining us today. We know your time is valuable and we appreciate your participation. If you have any questions or would like more information, please feel free to contact us by visiting our website at www.solidscape.com. Thank you so much for joining, and have a great rest of your day.